Wednesday we going to have the performance measure, and we have this. So we have this system size. And also we have the corresponding system time or working time. Because of the closed load. Alright. And actually we have the relationship if we have Q. So we have a time in Q. And also service time. Service time actually we can have the mean service time, but we can have 1 over mu normally. So we have these. Alright. And so then we can have WQ. Right, this one. And once we have a WQ again, we can have the equals load. Alright, so I did not follow the way to derive the full performance metrics. In fact, the task will try to rederive LQ again and then apply equals load to find these, but I reverse it. So we have the way to have the full performance measure. Once we specify one, or maybe we derive one, and then we can have the results. Well, that's it. So that's M1. And later, similar relationship can be applied to the generalized system. Later we can know it is called MG1. But before we go, we have MMS queuing system. MMS says, oh, we have S circles. Alright, S circles. Well, if so, what it means, we have 1, 2 to S. So we have S circles. As for the Q, infinite size. Well, so how to have the stationary diagram? Look at this again. The maximum rate. The max service rate, we have S multiplied mu. So stationary diagram looks like this. Maximum, so if we have 2 customers, only 2, because 2 customers will be served. So rate 2 multiplied mu, 3 to S here. And so that someone reach the maximum rate as mean. Alright, so this is a way to have the state transition diagram. And this time I emphasize the state transition diagram. I think based on the derivation for M1, you will know how to have the state transition or balance equations. So based on the balance equation, then we can derive. So I skip some details. Based on the balance equation, we can derive this. D of I, and once we have D of I, how to have the system length? Same, we have I, 0, I equal to 1, 2 to the other. So this equation is the same. And it can be proven we have this one. So I do not check it further, but at least I get have the way how to have the calculation. Based on the steady state equation, then we can find this. Once we find this again, we can apply Little's law. And Little's law over rate, so again we can have this. Alright, so follow that way, we can have this one. Well, of course, so this one, maybe it is not really correct, so this time follow this. If we have a cube with multiply I minus s, because here we have the server 1 to s, so minus s and then a start from s, and then we'll stay in cube. Alright, so this one, find it, then again apply Little's law. So we have this result. Alright, so this is MM1. Because of the deviation from MMS, because of the way to derive the result from MM1, so I go quickly and allow you to know, oh, okay, follow the way, then we have the results of MMS. Alright, that's all. But something wrong with this, so let me readjust this one. Alright, so maybe let me check it again. So that's it. So I have for the extension to MMS. And about this, let me know your status. Any questions? So that I have 1 minute check. Okay, so that's one. And that's one, actually I upload the video to YouTube even it's really late, maybe near midnight, right? And we have MG1. Alright, and of course you can check the video for sure. So here. We have an MG1. And actually later, I have the overview of the remaining part for the MG1 case system, so this one. And after that, I provide the supplement to the MG1 case system, the approach employed by the task group. It is called this one, matrix-geometric approach to MG1. And in fact, we can have an alternative. So we have a mean value approach. So you can check the 3 videos. Alright, now let me check these. Alright, so of course feel free to check it, but we have these questions. First of all, answer the following 2 questions. First one. If we have time and we have MD1, so queuing delay. Compare the queuing delay, the formula, and which one larger. Alright. And the second one, MG1, MD1, and MM1. If you are asked to apply the queuing model to analyze the system code, AIQ system, which one you think? Well, shoot. The analysis of the AIQ queuing system. And what's the reason? What are the reasons? Alright, so about this, allow you to have 5 minutes to discuss with your members. Okay, and again, readjust the table so that you can get together to discuss this. And feel free to share the video if you don't have any idea. And this you can get closer. So, belong to good too. Actually, some results are included in the video. Sure, you can check it. So feel free to discuss with your partner. So move your table so that you can get closer. Then for your after you can try to download this video. So I don't know, any idea about the two questions? Actually, you are asked to answer however, before you go, let me have maybe so we have 4 and sorry, not this one. And go on, focus on problem 1 and select 1 to serve as the presenter. What's the result if you compare the two systems? And go to the same. Alright, problem 1, go to. Later one, you serve as the presenter. Group 3 and 4, focus on the second problem. 3 and 4, second problem. Ready? So, right now, for the presenter, start the Skype. So let me start the Skype. So for the presenter, at least you need to join Skype. And this time, I set myself to mute. So later, if you are the presenter, you can turn on your microphone. And of course, my microphone here as well. Alright, so group 1 and 2, problem 1, which one ready? Ready? Okay, join the Skype virtual. And go to ready. Okay. And go 3 and 4. Any team ready? Okay. Alright, so that is how for 30 minutes further. Firstly, I think you know the problem, right? Should we have the problem again? The problem, take a picture for this page, and so they have your own problem. And later, if you are the presenter, then you can show the result. Alright, so this one, good one. Okay, so good one already and mentioned how you have the result and how to compare the result. Who is the presenter? This is all. So right now we have the answer shared by group 1 and the presenter is you and then English. Jen. Okay. Ready? Go.
We compare the D1 and D1 and we have D1.
Speak louder. Wait a moment. Wait a moment. Yeah. Now you can continue.
Okay. We compare the D1 and M1. We have a conclusion that D1 is a more queuing, steadily queuing than M1. Because we have those two conclusions and MD1 is for conclusion and we can see MD1 equation due to the reducible time variability. So again, we can see.
No problem. Keep going.
We have also equation. I think MD1 is more time.
Okay. So how you compare these? Which one larger?
I have no idea.
And one larger, right? And how you have the equations, the two equations? From which model?
What was in the PPT?
PPT and PPT and video, and also the source. I mean the source coming from which model?
The source, you mean?
I mean the original source to have the formula.
It's just MM1 from what we've seen in the presentation.
Yeah, MM1 from the presentation is okay, but MD1.
And one we search in the internet, we didn't find it.
You find it, so find it based on what kind of model?
It didn't say anything.
It should be MG1, right? And MG1, can you let us know the formula of the original MG1? Formula?
MD1.
Yeah, M21 formula so that we have the queuing delay. And you show the results MG1. Can you show that one?